Making better defensible decisions. This is about the use of decision validation and decision zone mapping techniques. Let's start by asking a very simple question. Would you give your car to a mechanic who is not trained? Probably not. Would you go to a dentist who is not trained? Certainly not. But why not? Because you firmly believe that he might mess up your car and your mouth, and also that a trained person is likely to perform better. In that case, what about untrained decision makers? Are they not likely to make some serious mistakes one time or another? Let's look at a typical problem a company might face: the purchase of a laptop. The IT department might start with some criteria such as screen size, processor speed, RAM, hard drive, etc. Then they look at the available laptops. Then they gather the information in the form of a table. As you can see here, we have the criteria. Here we have the candidates, the prices are there, and the properties are there. So how do we make the decision? Different people have different approaches. Some might pray for divine intervention. Others might seek advice from fortune tellers. We know the famous case of Nancy Reagan often relies on fortune tellers. Some use dictatorial methods. Others decide by teams and consensus. Some follow established rules like judges. Your weatherman relies on pattern recognition. So do insurance companies. Tradition and superstition. You will see that even a company like Boeing does not have a row 13 in a plane. Companies that build high-rises do not name a 13th floor. What about gambling? Relying on intuition and gut feel, logic and experience. We even postpone and delay hoping it'll go away, or we delegate to others. But what about analytical methods? That's the subject today. Let's reflect on some of the well-known disastrous decisions made in the past.
It's natural to think that judgment, experience, intuition, logic, common sense, etc. is the way to go. In the good old days, this is how great leaders went about their business. Of course, you don't hear of the sob stories and the fiascos. For example, TWA and Pan Am, the pioneers of air travel, are no more. Bad decisions at Kodak led to their bankruptcy. Billionaire Ross Perot admitted that two of his worst decisions were turning down early partnership opportunities in Microsoft and Home Depot, each worth billions of dollars today. In 2000, Yahoo rejected a $44 billion bid from Microsoft, and then in 2017, when Yahoo was put up for sale, Verizon grabbed it for just $4.5 billion. When startup Netflix approached Blockbuster CEO to partner with them, he laughed at the proposition. A few years later, Netflix forced the bankruptcy of Blockbuster. Coca-Cola, for example, invested millions of dollars in developing and launching new Coke, yet they were forced to withdraw it just 3 months after launch. As you can see, bad decisions can have catastrophic consequences.
So as you can see, famous companies with top-notch professionals have gone through hell because of bad decisions. The starting point to making a decision is a problem. So we start with what is considered as problem solving. That means we first see a symptom. Let's say, for example, you have a son whose foot swells when he runs. So that's a symptom. He goes to a doctor who identifies the problem as being flat-footed. He offers the following solutions: keep it on ice, bandage it, wear special shoes, or surgical intervention. So you have to make a decision. Let's say we decide on putting some shoes. We have to validate that decision. We'll get to that in a minute. And finally, we must implement this decision. So as you can see, there are 6 steps to solving a problem. Today, we are going to focus on steps 4 and 5. That is making the decision and validating the decision. Because problem solving is not decision making. Problem solving is unique to the problem, to the domain expert. Decision making is unique to the person. It's about human judgment. To elaborate this further, imagine you're on your way home after work and the red light comes in to say service engine. So you go to Jim, your mechanic, and says, hey, Jim, I got a problem here. So he says, okay, let's run the diagnostics. He comes back and says, you've got a gear train problem. So your first question is, hey, Jim, what should I do? So he says, we could repair it, we can replace it with the repaired unit, or we could install a brand new unit. While you ponder over it, he says, hey, Doc, your car is a bit old, why don't you sell it? So who did what? Jim solved the problem, but you must make the decision. For example, the president of a nation or an organization does not solve problems. He or she makes decisions. Now, if you think you're in total control of your decisions, think again. You will soon see that we are all chained to our biases that are inherent in our DNA. Others constrain the environment to shape our decisions. Some others even intentionally manipulate our thought process with well-designed techniques. These have been well documented through responsible research. So the first question is it possible that the decisions we make has something to do with our DNA? That we are born with our own fears and biases? Well, here's proof.
Dr. Chopra comes at this as a doctor, as a scientist, and a very eloquent speaker, given us so much to think about.
We've been able to look at the brain. We've been able to look at gene expression. We've been able to look at cell markers of aging, telomerase, telomere length. We've been able to look at what are called inflammatory markers. In other words, everything that's happening in the body at a biological cell level. 23,000 genes, 3.3 million bacterial genes. Actually, your body is more bacteria than it is human cells, the microbiome. So we're looking at those genes. And then we're looking at what is called the epigenome, which is the shell of proteins outside the genome, and how these work together. And what we are finding is remarkable. You know, in the beginning, nobody would believe us, but now we have collaborations with Harvard, UCSF, UCSD, Scripps, with digital technology, with Duke University, with Mount Sinai. We can look at a blood sample, and we can tell you if you're experiencing samadhi occasionally or not, if your mind is quiet or not, if you're falling into the place where he
Even
has...
whether our parents experience this.
Parents too. In fact, the epigenetic shows that your experiences now, which are not in your brain, by the way. Everybody says, my experience is in my brain. It's not in your brain. Your experiences are not in your body. Your experiences are in a non-local consciousness, which is not in space-time. In Hawaii, they have these temples and cow farms. If a cow has been zapped electrically, the next generation of cows will not go to the fence. They already know it's electrical, and they might get shocked. Okay. Then the following generation. Now, people have done experiments right here where you take mice and you have them smell wintergreen, which is a very pleasant smell. Then they get mild electrical shocks. The next 7 generations of mice will be scared by smelling wintergreen. Where is the seat of this personality? Where is it coming from? This is why science opens the window to what people already knew, actually, in our tradition.
Conclusion. Our decisions are highly subjective and biased because they are tied to our ancestral past. Let's face it, most of us make decisions relying on experience, judgment, common sense, etc. Sure, they were sufficient in the past. But in today's world of information overload, big data, and VUCA, we need more reliable techniques for making consequential decisions. Let's talk about modifying the environment. This is an example of what we call persuasion, not persuasion.
Yes, persuasion.
Persuasion is the practice of getting people sympathetic to your message before they experience it. It is what you say immediately before you deliver your message that leverages your success tremendously.
And persuasion demonstrably works by prepping the mind for the message.
There's this interesting study. A guy goes to a shopping mall in France, and he tries to get women's phone numbers as they pass various shops so he could call for a date. One of them is a shoe store, and another was a bakery. But in neither of those cases was he very successful. He only got a number 13% of the time. But there was one kind of shop that doubled his success rate when women were passing it, a flower shop. Why? Because flowers put women in the mindset of romance.
Not consciously, persuasively.
If we are paying attention to something important, that's how we decide to pay attention. But a communicator can reroute our attention to something that isn't important, but make it seem important as a consequence.
Now, marketers, some of them, have studied persuasion's potency. One online furniture store tested images of fluffy clouds versus cold hard cash on its homepage.
Those who saw the background depiction of clouds searched the site for more comfortable furniture. Those who went to the site that had money in the background became cost conscious and preferred to purchase less expensive furniture. Almost no one recognizes that the clouds or the coins had any impact on their behavior, and yet it did at...
What about manipulating, messing with your brain? Well, here's an experiment from Yale University.
What we do in our experiment, we very briefly expose people to a warm or cold substance. And what we expect to happen is that that simple experience with a warm substance or a cold substance will prime people to sort of activate these feelings of warmth and comfort and the things that we've learned about since we were very young.
Volunteers for the experiment are asked to hold a warm cup of coffee as they are met by Lawrence. They have been primed with heat. The purpose of the experiment is to record participants' judgments about Lawrence's colleague, Randy.
How was your break?
It was awesome.
It was good until I got stranded in Florida.
What happened?
Because of the snowstorm in New York on Friday, so I got stranded.
Cup. And here's the killer question. Would you give Randy a permanent job?
Based on your brief interaction with Randy, or would you hire him as project manager?
He seemed like a generally friendly guy.
So yeah, I would say so.
Yeah, why not?
Sure. Yes. Yes.
Saying warm and friendly things about a stranger might just be the normal polite response. Time to cool things down. Except for the temperature of the drink. Identical conditions. The same conversation with Randy.
How was your break? You glad to be back?
Not really.
And 6 minutes later, the same questions from Lawrence.
Based on your brief interaction with him, would you recommend him or would you hire Randy as project manager?
As a leader? I'm not sure. Based on the brief interaction? No.
Maybe not from the impression that I got.
The experiment shows, remarkably, that a brief encounter with a beverage could see you either hired or fired. It's a powerful effect, and one that might have worrying applications.
So the recommendations are, at a business meeting, serve hot drinks instead of something cold. And if you're on a date, order a hot soup instead of a salad, because your thoughts can be manipulated.
Dr. Daniel Kahneman received the Nobel Prize for his work in the area of behavioral economics. Here he speaks of the two systems that we humans rely on to make decisions.
At the heart of human thinking, there's a conflict between logic and intuition that leads to mistakes.
You know, our mind has really two ways of operating, and one is sort of fast thinking, an automatic, effortless mode there. Everything that you see and that you understand, you know, this is a tree, that's a helicopter, that's the Statue of Liberty, visual perception, all of this comes through system one.
The other mode is slow, deliberate, logical, and rational. There's a system two.
What's the best example of the two systems? There's really 2 plus 2 is on one side, and 17 times 24 is on the other.
What is 2 plus 2? 4.
4.
And what's 2 plus 2? 4. 4.
It is automatic. It just happens to you. It's almost like a reflex.
And what's 22 times 17? Ooh, I think it's a good one.
But when we have to pay attention to a tricky problem, we engage slow but logical system two.
Well, that involves work and it involves concentration.
And can I get you to just walk with me for a second?
System two may be clever, but it's also slow, limited, and lazy.
If you are expected to do something that demands a lot of effort, you will stop, even walking.
51. 16.
This past year concerns this nice bottle of champagne I have here. Millicene 2005 to give you a tenderly nice vintage bottle.
These people think they're about to use slow, sensible system 2 to make a rational decision about how much they would pay for a bottle of champagne. But what they don't know is that their decision will actually be taken totally without their knowledge by their hidden, fast autopilot, System 1. And with the help of a bag of ping pong balls, we can influence that decision.
I've got a set of number balls here from 1 to 100 in this bag. I'd like to reach in and draw one out at random for me, if you would.
First, they've got to choose a ball.
Number says 10. 10. 10. 10.
They think it's a random number, but in fact it's rigged. All the balls are marked with the low number 10.
What we do is purposefully we give people a first decision that is clearly meaningless.
10. 10. Okay. Would you be willing to pay £10 for this nice bottle of vintage champagne?
I would, yes. Yeah, yes.
Okay.
This first decision is meaningless, based as it is on a seemingly random number. But what it does do is lodge the low number 10 in their heads. Now for the real question, where we ask them how much they'd actually pay for the champagne.
What's the maximum amount you think you'd be willing to pay?
20?
Okay. £7. £7. Okay.
Probably £10.
A range of fairly low offers. But what happens if we prime people with a much higher number, 65 instead of 10?
What does that one say? 65. Okay. Okay. It says 65.
How will this affect the price people are prepared to pay?
What's the maximum you would be willing to pay for this bottle of champagne? 40?
45.
45. Okay.
50.
40 quid. Okay.
£50?
£50?
Yeah, I'd pay between 50 and 80 pounds.
Between 50 and 80?
Yeah.
Logic has gone out the window. The price people are prepared to pay is influenced by nothing more than a number written on a ping pong.
This is a case of meaningless options being introduced to influence your decision. McDonald's uses this technique very effectively. If you look at the pricing of McDonald's fries, you can see the small cost $1.39, etc. If you divide this by 2, 37 grams of fries will cost you 70 cents. But if you move from the medium to the large, you can get 35 grams extra for just 10 cents more. So for McDonald's, the medium is a ghost option that they place intentionally to move you to the larger fries. The next thing is to recall the unconscious biases that we spoke of. There are far too many for me to discuss, but here are some of the well-known biases. Loss aversion bias, interest bias, tribal or social bias. This is a good example of what's happening today with the Democratic and Republican parties. Overconfidence bias, pattern recognition bias, the introduction bias or priming, the confirmation bias, and the well-known recency bias. I won't elaborate on every single one, but if you have any questions, please ask me. Hopefully you're convinced that in today's world of big data, you're likely to make suboptimal decisions. But what can we do about this? See, decision making is part art, which is all our feelings, and part science, which deals with uncertainties and probabilities. But what triggers the need for a decision? It is change. Without change, you don't have to make any decisions. But change happens or we initiate change. That gives rise to conflicts. The causes are many. Definitions, interests, values, emotions, roles, styles, time, etc. But this leads to problems and opportunities. I refer to them as probs. We naturally have to find a solution. And of course, with many solutions, you must select one, which is the decision. So as you can see, whenever there is change, you're going to have to make a decision. The typical decision-making process starts with an objective, then a set of criteria, and potential solutions, or what we refer to as candidates. So this is what we call the CNC, criteria and candidates. We naturally need a process before we can reach the decision. Now the decision maker's role, once the objective has been defined, is to identify the criteria. These are the wants and the needs and the assumptions. And then identify the candidates. And finally, interpret the data in the prevailing environment. This is where feelings come into play. As we search for the optimum decision, The quality of the decision will depend on the data and the information you have, the context information, creative options, the solution techniques used, and the decision maker's expertise. However, the implementation must factor appropriate timing, adequate resources, commitment to execution, and of course changing circumstances. The outcome depends on the quality and its implementation. That is why we say that do not judge the quality of a decision by the outcome, because the outcome is tied to implementation. You can make a good decision but have a poor implementation. And now, of course, the decision maker has to deal with politics and stakeholders, because we have the problem solvers, the information providers, the implementers, the people impacted both positively and negatively, and of course a manager with the budget and the authority and the desire. So the decision maker must interact with all of these people as he moves along the decision making process. Let's look at a problem with multiple criteria. Imagine you just won the green card lottery and you're planning on moving to a suitable location in the USA. How would you go about deciding on a place to live? So you ask for my help. So I start with a set of criteria. These are typical criteria like average temperature, cost of housing, availability of hospitals, pollution, crime, etc. Here I have 7 US cities. These are actual cities with data from the internet. Can we now make a common sense decision? Oops, too much information. Ladies and gentlemen, it's not that it's too much information. It's simply that you have not been trained to handle big data. This could be selecting a supplier, hiring an employee, locating a branch office, or even procurement. For this, we have developed a 7-step approach that is very reliable. Step 1, clearly define your objective. 2, identify all relevant criteria. 3, conduct criteria segregation. 4, identify all available candidates and options. 5, gather information and create a judgment table. Assign weights to obligatory criteria. And finally, rank the candidates. As you can see, steps 3, 6, and 7 have the letters AHP, which stands for Analytic Hierarchy Process. This process is extremely well known. You can just simply Google it and you can see that the last conference had 90 papers and 19 countries were participants. It has been used in many real-world situations: site selection, subcontractor selection, bid evaluations, even the US Defense Department's military base closures, risk analysis, etc. So let me present to you the AHP technique. All decisions are based on some form of comparison. We cannot look at this picture and say this person is tall or short. But when we compare him to another person, we see that he is short. Thus, all decisions are relative, not absolute. Imagine you're at an airport lounge and you're watching the TV screen and 2 pictures are presented. And you're asked to distribute 100 points among these ladies. 60-40, 30-70, whatever it is. Difficult? Probably not. Now you're shown 4 pictures and asked to distribute 100 points. Difficult? Probably a bit more. Now you're faced with 7 pictures. This time it requires much more attention and you're probably ready to give up. Let's get back to the pair. Would you say that the pair was the easiest to handle? Obviously. Would you agree that as the number of contestants increased, it became increasingly more difficult to make a reliable judgment? Let's take a look at a problem in the real world. Your manager wants to promote you but wants you to find a replacement. So you start with a set of criteria. Here we have 37 criteria and you're asked to select those that are applicable to your particular job. You might select 10, 15, whatever the number is. Now imagine 7 candidates are presented as well. Now in the previous example where I presented pictures of ladies, I only showed you the face. I did not show the body, the walk, the talk, the swimsuits, nothing. And even when you dealt with one single criterion, that of beauty, you had difficulty deciding between the 7 candidates. How do you think you would handle 10 or 15 criteria? It's almost impossible. Additionally, there are multiple decision makers. How would you make a defensible decision? This is a 3D problem with multiple criteria, multiple candidates, and multiple decision makers, most certainly beyond common sense decision making. Imagine you're selecting compressors and you're faced with 13 criteria and 7 candidates and 4 departments. This would be a nightmare for common sense decision making. Hopefully by now you're convinced that without a robust technique, you're likely to make some serious mistakes. Now let me elaborate exactly how the AHP manual technique works. Considering only a pair of elements, we express the dominance of one over the other using a scale. Now by dominance we mean the importance or the preference or the likelihood. If you're buying a house, you might consider price and distance to work. And the scale of dominance is, are they equally important? One is weak superiority, moderate superiority, strong or absolute superiority. Here we are interested in the difference which is natural for humans. Imagine you come home to my place for dinner, and after dinner I say that you can have a choice of cake or fruit salad for dessert. And I'll ask you 2 questions. Which one do you like more? And you say cake. Then I'll ask you, how much more do you like cake? You can look at the scale of dominance and say moderately. Ladies and gentlemen, even the most complex problem can be boiled down to these 2 simple questions. Which one and how much? This video elaborates this more.
Multi-criteria decision-making using the analytic hierarchy process. Most of the decisions we make in the real world are multi-criteria in nature. Typical examples would be procurement, recruiting, local branch offices, etc. The best way to explain this is to consider a hotel chain hiring a business development manager. They identify 6 criteria and 4 candidates. Let us now look at the AHP software that we have developed. I have set up the recruiting problem, and when I hit continue, we have the criteria and the candidates that I have already inserted. We move on to the judgment table. The criteria judgment provides pairwise comparison. All you have to do is remember 2 simple questions. Which one? How much? So the first question is between availability and leadership. Which one is important to us? Availability. Then between availability and salary, you might say salary. You proceed with this, and when you finish, you simply say OK, and you hit continue. Now you are presented the candidate judgment, which is identical with the previous case. On this occasion, you're offered 1 criteria with multiple candidates. Once again, we answer the 2 questions. Which one? How much? To say which candidate is more important than the other one and to what degree. We do this for each criterion. When you finish, press OK, and we are presented the criteria weights and the candidate rankings. Once we complete the evaluation, we generate a graph using the chart maker. We see that the optimal decision is Mary. Additionally, we have 6 bands. This is known as the N-1 evaluation. Here we have removed availability, here we have removed leadership, and here we have removed salary, etc. And if salary is not an issue, Sue is a far better candidate. Could you have made better defensible decisions relying on common sense alone? Probably not. Cost-benefit analysis with sub-criteria. This is a very specific application of the AHP technique. Consider typical decisions most of us face, such as bid evaluations, buying a home or a car, selecting a consultant, recruiting problems, deciding on how much insurance, site selection such as retail outlets, scheduling priorities, etc. These types of decisions are all driven by associated criteria. The cost-benefit analysis is ideally suited for this type of problem. But to simplify the discussion, let's consider the purchase of a lamp. Here we have the criteria. Here we have the candidates. And we have the sub-criteria information which appears as data. The first thing we have to do is run the AHP evaluation to determine the criteria weights. Make sure you do not use price in the AHP evaluation. Now we have the criteria weights. Note it has to add up to 100. The next thing we do is we run the AHP evaluation on the sub-criteria and we enter the corresponding weights in these pink cells. Once this is complete, we simply look at our cost-benefit data and plot a graph. This happens automatically within our software. As you can see, the Acer and the Dell are comparable in terms of benefits, yet the Acer is significantly cheaper, so it is up to the individual to decide whether to go for the Acer or the Dell. There are a whole host of applications for this type of evaluation, limited only by the imagination. We encourage you to consider using AHP with sub-criteria when the consequences of a suboptimal decision are significant.
What we just saw was problems with multiple criteria. Now let us look at a problem with multiple uncertainties. Imagine you have a small business that you run from home and you got a contract to supply some minerals to Intel. But unfortunately they are available only from 3 West African countries: Angola, Congo, and Liberia. Availability, price, and air freight are all equal. You must buy only from one country because of volume discount. You speak to our embassy in these countries and you're told that all of these people have political instabilities that could disrupt supplies. Can you make a common sense decision on the best source? Not really. It doesn't matter. Why? They're all the same. But what additional information would you like or want? Maybe something about the likelihood of these events happening. This is known as event probability. So let me give you the event probabilities. There's a 25% chance of riots in Congo, 30% chance of a coup in Angola, and 35% chance of a new government in Liberia. Can we now make a common sense decision? Not really. We need to know about the impact probability. How would this impact us? So now I'll give you the impact. In the case of Congo, with the 25% probability of riots, there's a 20% chance we will have zero loss. There's a 50% chance we would lose 30% of our contract, and a 30% chance that we would lose 40% of our contract. Now we have an understanding of the impact. What about the other 2 countries? We have similar impacts. Ladies and gentlemen, we now have 21 data points. Can we now make a common sense decision? Oops, too much information. Again, ladies and gentlemen, it is not too much information. It's simply that you're not equipped to handle problems with big data. Since I refer to event probability and impact probability, I think I should elaborate this further. Let's take the case of a car crash and a plane crash. Imagine you're going home tonight. Is there a possibility of a 10% chance of having an accident, somebody hitting you from behind? That is called the event probability. The impact probability on your car is 50% that it would be damaged. And the impact probability of you getting hurt might be 20%. But in the case of a plane crash, the EP is 0.0001, the likelihood of a plane crashing. But the impact is pretty serious, that you would die. So ladies and gentlemen, when dealing with uncertainties, we must consider both the event probability and the impact probability.
Single criterion decisions with multiple uncertainties using decision trees and D-zone maps. GenGen Pharmaceuticals is developing a new drug for the treatment of diabetes, thrombosis, and cholesterol. However, GenGen can invest only in one of these projects. The cost of pursuing these products for the preliminary test, they have to spend $2.5 million. And for FDA approval, that would cost $500,000. The marketing department has arrived at potential revenues from these projects. Here too there are some uncertainties. There is a potential for high revenue or low revenue. For example, for cholesterol, the high revenue would be $13 million, while the low would be $7 million. Uncertainties facing GenGen are: will the preliminary test be successful? Will the FDA approve the new drug? Will sales generate the projected revenues? The question for GenGen is, which project? We can start with a 50-50 assumption for all uncertainties, and then study the impact of such assumptions on the final decision. Action plan: first draw the DT sketch, then develop the Excel model, then plot the D-zone map, and finally study the uncertainties. Here we have the sketch for the decision tree. We have 3 options, and let's focus on thrombosis. If the preliminary test is successful, then we proceed for FDA approval, and if the approval is granted, we proceed to market. And there is the potential for high revenue or low revenue. Similarly for the other 2 projects. Now to step 2, where we build an Excel decision tree, and in this case, it's for the preliminary tests. Once we complete the decision tree model, with one click we can create the D-zone map. The model creates 3 zones for the 3 decisions: thrombosis, cholesterol, and diabetes. The zone in which the red pointer lands is the recommended decision. In this case, the recommended decision is to go with the diabetes project. Here we have 3 axes. One is for diabetes, the next is for cholesterol, and up here is the thrombosis. When I change the probability of success of thrombosis, the decision is thrombosis. If I change the probability of success to 70%, again, the recommendation is thrombosis. What is important to notice is that the distance of the pointer from those demarcation lines tells you the degree of freedom you have with regard to your assumptions. In this case, when the probability of diabetes success drops below 46%, the decision should be for thrombosis. Zone maps such as these give you tremendous flexibility to understand the sensitivity of your assumptions to the final decision. We repeat the same process for the FDA approval and the projected revenue, and we can see under all 3 scenarios the recommended decision is to proceed with the diabetes project. Could you have made better defensible decisions relying on common sense alone? Probably not.
Sure, anyone can make a decision and live with the consequences of a suboptimal decision. But it will be very difficult to defend such a decision in a corporate setting. You must incorporate analytics to reinforce your common sense. Hopefully you're convinced. Thank you.